in the previous video we have seen how to plot for the transfer function 1 by s. Here we will see how to plot for the transfer function 1 by s power n. So instead of s power n, let us take the value of square s square, and we have seen straight away that it is in the denominator, so there are poles available for us, so there is no zeros here. So the question next comes is how many poles are available for us. So it becomes s square, so the power says that you have 2 poles. Okay. Now since we have 2 poles, so whereas the location of the pole will be of s is equal to 0, s1 will be equal to 0, again the same s2 will be equal to 0. So that means at the origin, if I take this as a 0, I have 2 poles available at the origin itself, s1 and s2. Okay. So the first rule is substituting s is equal to j omega, then I will get the transfer function. So instead of s square I have written s into s. So we will see how we can have values. As I have told, there are 2 poles available at the location 0. Now we will changing the omega into this one. So now we have to find the gain and the phase. So how we can find the gain formula? The gain formula is given by 20 log of k divided by omega square will be there. No, k divided by omega. So before going to this one, so let us solve this one. So it is a mod. We have to take mod g of j omega h of j omega, which is nothing but equal to mod k divided by j omega the whole square. Right. So if I take a mod, so the value will be equal to k by root of 0 square plus omega to the power of 4. So which I can tell it as k divided by omega square. So this will be the value for g into j omega into h of j omega. Now if I substitute this in the 20 log, so there is a 20 log of so if I substitute here, this will be 20 log k divided by omega square, so which I can rewrite it as 20 log of k minus 20 log of omega square, which again I can write it as 20 minus 20 into 2 log of omega. So this is the power. So this is taken here. So in the general term we can write the same expression as which is equal to 20 log of k minus n into log of omega. So this will be our expressions, so where we can calculate the values. So here it is given as a 20 log of omega, so here the value will be of omega square, and here also the value will be of no. So here what I have done is I have calculated it separately. So we can use the previous formula. We can either use this formula, or I can calculate it a gain 1 and gain 2, and I can finally have a total phase and total gain. So if you look at the gain 1, which is similar to the previous session, so k divided by omega, so I'll get a 20 minus 90. Similarly for the gain 2, I'll also get the 20. So this is gain 2, not the gain 1, and minus 90. So if I add these two things, I'll get the value as 40, and here the value will be 0. Here minus 20 plus 20, I'll get the value as minus 40. Now the phase remains same. There is no change in the phase. So if we try to plot the final these two values in a Bode plot, this is the one we are going to plot in the Bode plot. Either you can do like a table, or you can use this previous formula to find the expression. So if you plot this one, so if you take k divided by 10, so then the omega value is 0.1. So I can take omega value is equal to 0.1 and k is equal to 1. Then what happens? So I'll get the value as 40 here. Okay. Now if you take the second scenario, it is 0 at omega is equal to 1. Omega is equal to 1. That gain will be equal to 0 for us. So here value is 0, and similarly 10 more minus 1, I'll get the value is 40. So if we draw a line, so this will be the line for us, and phase is just a 180 degree line.